In this video, we are not going to build anything new. We are going to fix something that's broken, and we are going to use the debugger to do that. So I have a virtual pet simulator over here on the right that is working, that does what we expect it to do. So this is a modified version of the code we wrote in a previous video, where we were creating individual pets as instances of a virtual pet class, and then we were having each of them print some information out. So we can see we've got Leo, Junior, Callie. They each have their own color. They've got this happiness bar, and the two of them have these these toys. One's a red ball, one's a squeak toy, and each of them is able to eat something. So we'll see how the code is structured in a second, but this is the working version of our application. And over here we have the broken version that we are going to use the debugger on. So we can see that none of the color information has worked here. Some of our pets are printing out the information in the wrong order. Our happiness bars are broken. Our toys are missing. The food eating printout is broken. So we've got a lot of bugs. None of these are bugs that prevent us from compiling our application. They're not compile errors, but they're logic errors. We did something weird in our code, and the result is that even though the code runs, something unexpected has happened. There are a lot of ways that we can approach fixing these bugs, tracking them down. So we could just look at our source code and try and reason about what's happening. We could do console write line all over the place to print out the state of different variables to see what's going on. But the most powerful tool that you can use is the debugger for situations like this. So the debugger is a tool that allows you to watch your code as it executes. So you can go line by line. You can watch all of the fields, all of the variables, all of the methods as they're executing. And when you do this, this helps you track down those bugs. You can see like, oh, this variable doesn't have the right value that I was expecting. So now I can, trace that and figure out where the unexpected value is coming from. The debugger is also a good learning tool. Anytime you encounter unfamiliar code, you can watch it execute line by line and watch what the code is doing so that you can understand exactly how your code is executing. So before we get into it, I just mentioned that there may be concepts that we haven't covered in this video in terms of the code, or if you're watching this out of order from other videos, you may see things you haven't seen. That's completely fine because the debugger will help us actually understand what those unfamiliar bits of code are doing. So for following along, I will have starter files linked, which is this broken version of our project. And it has a world class, it has a virtual pet class here that stores name, happiness, species, toy, color, a toy class for representing the toys that we're giving to those pets that have a name and color. And if we look at our program, our entry point, what happens is that we create a new world and we tell that world to run. So this is going to have a similar structure to the virtual pet simulator that we did previously. So to get our debugger to actually open up and let us watch the code execute line by line, we need to put a breakpoint into our code. So a breakpoint is a spot that pauses the execution of your code and turns over control to the debugger. You can insert breakpoints on lines of code by coming over to the left of your line numbers in the gutter here and clicking. And as soon as you do that, you'll see a red circle pop up and the line will be highlighted in red, indicating that this is now a breakpoint. So as soon as we hit play and the runtime engine hits this line of code, we're kicked over to the debugger. So if I hit play right now, our console window pops open for a second, and if I Alt-Tab, I can bring it back. We can see that it's empty. The title hasn't been changed, nothing has been printed out, and we are in debugging mode here. So we've got a couple of new windows down at the bottom that we can use, and we've got a couple of new controls up here in our toolbar that we can use. So the debugger is this whole thing that we're doing here that's allowing us to inspect our code line by line, and one of the easiest ways to trigger it is with these breakpoints. And we can put as many breakpoints as we want in our code. We can have multiple that we can trigger at different points. These will allow us to say like, oh, there's something wrong with our toy class. So let's drop a breakpoint in here and stop the execution when we go to display the toy's name so that we can see what's wrong with displaying the toy's name. You can remove breakpoints by double clicking or by clicking again on where the breakpoint is. If I go back to my main here, we can also, let's leave the debugger by stopping. We can right click and we can temporarily disable breakpoints if we want. So this breakpoint now won't run, but it is still there so that we can enable it again. And we can also make these breakpoints conditional. So if we wanted to break only after a certain condition is met, we can add that condition and have a conditional breakpoint. That's a little advanced. We're not going to use that. We're just going to start with having our initial breakpoint here and play around with walking through the code. So I want to make sure that I've got a breakpoint on this first line in our main function. Hit play. And now the tools up here allow you to do a few things. We saw the stop, which allows us to stop the debugger. The restart allows us to quickly restart the application from the beginning. Step into, step over, and step out are three tools that we're going to try and become comfortable with. These are going to allow us to navigate through our code line by line. So starting with step into, when we can see the hotkey here is F11, so I'm going to use the hotkey. Step into allows us to trace what's executing line by line. And if there's a function being called, like on this first line of code here, our constructor is being called, step into will allow us to follow that and walk into the constructor. So if I hit F11 here, we are now inside of our constructor. If I hit F11 here, we walk through the lines of our constructor. If I hit F11 here, we are now creating a new virtual pet instance. So we're calling the virtual pet constructor. So we should step into that virtual pet constructor here. And if we look at our bottom window here, there should be a call stack tab, which allows us to look at the sequence of functions and methods that have been called. And if you don't have any of these windows that I'm going to be showing you, you just come up to the debug here, go into Windows, and you can see down here, we could open up the call stack. Later, we're going to talk about autos and locals and in immediate. You can pop open any of those here. And you can also see our controls here are listed. So if you're having trouble locating them, they're also under this debug window. Okay, so with our call stack, we can actually see the order of the functions and methods that have been invoked. So down at the bottom, the first thing in the stack is our main. So we started here, and then we ended up in the world constructor. If I click on that, double click on that, it'll take me to where we were executing. We can see a little icon over on the side of where our breakpoints are to the left of the line numbers that tells us where the debugger currently is in terms of this context. And then this most recent thing in our call stack is the virtual pet constructor. So step into has let us walk through a few different function or method calls here, and we can see those listed in our call stack. And if I keep hitting F11, this will allow me to run through each line of code that's in here. So we can see now our full name has been set to cat, and our happiness level, which is 0 right now, will be set to 10 after that line of code runs. And our species is null, but after this line of code runs, our species is now Leo. So I can hover over variables that are in the current scope and see their different values, which we'll use in a second when we're debugging. So F11 allows us to track through the execution of virtual pet here. If I hit F11, as soon as we finish the last line of this constructor, we fly back up the call stack. So you can see our call stack now only has 2 things in it. We've finished with the virtual pet constructor, the right-hand side of this equation. If I hit F11, Leo the cat is going to go from null to an object that has been filled in. So it's now an instance of that virtual pet. And now we are on Junior the parrot. So if I hit F11 here, we will trace through the virtual pet constructor. But this time it's being run for Junior. So step into, you can think of as allowing us to drill down into the code. The opposite of that is step out. So this one over here, which the hotkey, at least on Windows, is Shift F11, allows us to jump up the call stack. So right now we're in this virtual pet constructor. We can see that here. If I hit F11, it's going to let the rest of this constructor run and take us back up the call stack to our world constructor. So I'm going to hold Shift F11. We hop back up to our world constructor here. And if I do that again, Shift F11, it's going to take me up the call stack back to our main function. So here we are, back at the main function. And if I hit F11, our world constructor is done, and now it will take us into the run method if I keep hitting F11 for step into. So we've seen step into, step out. I'm going to restart the debugger so that we can see step over. So we're back at that first breakpoint that we added here. I'm going to hit F11 to step into our world constructor. Hit F11 here. So if I hit F11, this would take me into virtual pet. So step into would take me into that new entry in our call stack. Step over, which is F10, allows us to stay in the current context. So stay in this current method, stay in the world constructor, and just skip to the next line. So F10 here, we don't go into our virtual pet constructor, but it still runs. And we can see that Leo the cat now has an instance set here. And Junior the parrot is null, and if I hit F10 for our step over, Junior the parrot has now been instantiated. So step into allows you to drill down, step out allows you to zoom back up the call stack, and step over allows you to stay in the current context and just move to the next line of code. Those can be tricky to wrap your head around, so what I recommend doing is just pausing the video here, opening this project, and just like using those, seeing what happens when you click those different ones so that you get a feel for what step into, step over, and step out do. The next one that I want to show you is super useful. It is run execution to here. So you can see that as I am hovering over different lines of code, there is this little kind of skip button that's showing up. This allows me to click to run my code until a certain point. So right now I'm in the world constructor, and I know this run method gets called after the constructor is done. If I want, I can jump directly to this first line in run by clicking that button. So I've now finished the constructor. I'm inside of run. This method is now going to be controlling the flow of what happens in the application. And actually, if I pull up my window here, now that we're over here, I can watch what happens as I jump around. So if I hit F11, our title, which is currently this, the name of where our file is executing, our title has now been changed as I hit F11, and we can see it changed in our console. And if I go ahead and use the run execution to here, so I'm going to run to right before this right line, and we can see that our clear took effect. So we set the foreground background color and cleared it to get everything to paint in that background color. And same thing, if I come down here and I skip over a chunk, we can see our virtual pet printing out here. So step into, step over, step out will give you a lot of control, and then this run to button allows you to jump around really easily through your code. And once you're done with debugging, if you want to, you've like learned everything that you need to learn from the debugger here, and you want to let the application just finish running, you can click the continue button, which leaves the debugger, or at least continues until the next breakpoint. And you can see here, our application has finished running because we have no other breakpoints in our code. So we should now be reasonably comfortable with just getting the debugger open and stepping around our code and watching it execute. Now I want to use it in context to solve some of our errors in our code. So here is the broken version, and here is the version that we want to have. So we can see that some of the color is broken. We'll have to look at our virtual pet for that. We can see that Leo in particular is broken. My name is Cat the Leo, which it should say my name is Leo the cat. Our happiness level is broken. We don't see any readout for this like kind of health bar, experience bar for the happiness level. And our toys aren't printing out. And lastly, our food line that's printing out here seems to be off. Some dry food is now eating some dry food when it should say Leo is now eating some dry food. So the process of using the debugger for this is we're going to try and identify where the problem is, put a breakpoint there, and then watch some of the code execute. So the first one we can solve is just this first line. My name is Leo the cat is coming out as my name is Cat the Leo. So it's perfectly fine if we wanted to just watch the whole thing by having a breakpoint here, but if we have a suspicion of where the problem is, we can put our breakpoint closer to the source of the problem. So here, I know something is going wrong with Leo, so I'm going to start here where Leo is about to be constructed. So when I put a breakpoint here, that'll allow me to walk into the virtual pet constructor and see what's going on. So I'm hitting play, my constructor, my debugger takes over here, and now we can step into the virtual pet constructor and see what's happening. So I'm going to use the step into because I want to go into virtual pet. And now that I'm in virtual pet, we've got a couple of ways that we can inspect what's going on. We can just hover over our fields and see what their current values are, and hover over our parameters and see what their current values are. If we also look in our bottom left-hand corner here and go to the Locals tab, this will show you all of the variables that are available in the current context, in the current scope. So we can see our pet name, pet happiness, pet species, pet color, all of these parameters because they are in the current scope. They are in the scope of our constructor. And we can also see this funny thing called this, which is a reference to our instance that we are creating here of the virtual pet. And since the virtual pet is an object that has fields within it, we can expand this object and see the value of color, current toy, full name, happiness level, species, all of these fields. We can see their values down here. So this locals panel is really helpful. And again, you can find that from debug window locals here if you don't have it open. The autos panel is also useful. It shows you the variables that are on your current line of code and the preceding line of code. So because right now we are paused right here, we should see our current object are this, and the preceding line of code is back here in the world with Leo the cat, so we can see Leo the cat here. And if I hit F11 to step in here, and I look at my autos, we can see that's changing as I'm executing code here. So I'm going to stick with the locals panel for debugging here, and I'm going to use hovering over variables to kind of inspect their values. So we know that Leo, the name and species aren't appearing right. We're seeing something like when Leo down here is greeting, it's saying I am Cat the Leo instead of I am Leo the cat. So we can check our constructor to see what's happening there. So these 4 values that we specify here, these are the arguments that then get passed in and set to these parameters. So as I hover over them, I can see pet name. Aha, pet name is set to cat. And our happiness is set to 10, and our species here is set to Leo. and our color is set to dark magenta. So immediately, just from like hovering over these, I can see that, these two variables are swapped. The values that I passed in are wrong, so I need to fix that. I need to flip them around. So let's see what happens with these wrong variables here if I use step into to watch each line of code execute. And I'm going to have my this object, which is our current instance of the virtual pet, expanded so that we can see all of the values. And because our constructor has not run and we have not set any values for any of these fields, we can see that they start at default values. So our happiness level, which is an int, started at 0. And our color, which is a console color, started at black. And then these other three variables, our toy, our full name, our species, all started at null. So this kind of hints to us that all of our variable types have a default value. All of our data types have a default value. So some of our primitives, like our int, are going to have a default value that is a valid number. And some of them, like our toy, are going to have this special value called null, which is a value to indicate that there's nothing here. So it's not that we have an instance of a toy, we actually have a specific value that says there is no toy here. So all of these are the settings before we step into this code and watch it execute. So if I hit F11 here and let this first line of code run, where we can see our full name is null, now our full name is cat, because whatever was in pet name has now been stored into our field. So it doesn't matter whether I hover over this full name, or if I look down here, they all now say cat. And same thing with happiness level. It's currently 0, but it's going to be set to 10, which was passed in. We can see that change. And same with species. Species down here is now set to Leo when it was null before. And I'm going to hit F11 to fly back up here to our Leo to our world constructor, and actually we can see Leo the cat is null. So all of these have default values, all these fields, and all of these fields are null. And then after I hit F11, whatever is returned from our constructor is set into Leo the cat, which we can see here. And I can expand to see it's filled in with color black, current toy null, full name cat, happiness level 10, species Leo. So let's stop the debugger and fix this first issue that we've identified. So Leo and cat need to be flipped. And if I remove my breakpoint and run it, we should hopefully see Leo the cat instead of cat the Leo. So let's try this process again. We fixed one of the bugs. Another bug that we've identified is that all of these are supposed to be color-coded for our pet. These three lines, these three lines, but they are not color-coded for our current pet. So if we look back at our virtual pet, the thing that's printing out here is our greet method. So what we might want to do is throw a breakpoint into our greet method to see what's happening and why our color is not being applied. Because each of our pets here back in our world is being given a color. Leo should be dark magenta, Junior the parrot should be dark yellow, Callie the unicorn should be dark cyan. So back in virtual pet, into greet, throw a breakpoint, hit play. We are now close to where the error is, and we can actually see when we hit our breakpoint that we are in a call stack. So we started in main, run, then in run, we got to Leo the cat greet, and then now we're here at the first line of greet. So if we look at this chunk of code, we are taking the current foreground color and storing it into a previous color variable. We are setting our foreground color to our color field here, which is this field. We're printing out our name, we're doing another method, the happiness bar, the toy info, and then we're resetting our color back to whatever our stored previous color was. So now that we're in this function, if I just hover over things like foreground color, it's telling me the current foreground color is black. If I hover over color, the field for our color here is currently black. So even though we're in Leo, which should be dark magenta, we're seeing black. So that's our cue, like, oh, okay, something's gone wrong even before we hit our greet method here. And if I wanted to, I could just like hover over these, Leo, cat, and see that these values are the correct values. So we know that our problem is happening before this chunk of code. So what I might do is go ahead and remove this breakpoint, throw our breakpoint into our constructor, and restart our application. So we can see we're in a set of call stack. We've got a call stack already filled in here. We started at the world constructor, ran the first line where we constructed Leo the pet and passed in dark magenta. We're now in our constructor where I can see, hover over the pet name as Leo, look at our pet color, dark magenta. So we're getting our color. We just forgot to set it here into our field. So I can get rid of this breakpoint. I can fix this problem, give it a save, run it. And there we go. Our pet's greet information is now being color coded. And we can just repeat the same process to track down all the rest of our bugs. We've got a bug here where our eat logic isn't working right. So if I look at my world, we have Leo pick up a ball, we have Leo greet, we have Leo eat, and Junior eat. And then we've got the third pet eating here, which we can probably tell, oh, hey, here's another one of our bugs. Let's ignore that for a second. And let's throw a breakpoint here before the first pet eats. So if I hit F11, I am now here. You know, we can see that a chunk of our virtual pet has run right before we have Leo eat something. If I hit F11, we step into our eat function, our eat method here. We can see that what was passed in was some dry food. And if we look at this line of code, we can see that, oh, here's the mistake. This should be full name, not food name, is now eating food name. Remove the breakpoint, run it. Leo is now eating dry food, Junior's eating worm, Leo is now eating rainbows. So another bug solved. This third one, you know, we could do the same process that, you know, we've got 3 pets here, but this last one is a duplicate. So we would just, you know, throw a breakpoint in here and see what's happening. And we might then notice that, oh, we used the wrong pet here. It should be Callie the unicorn instead of Leo the pet. I'm just going to fix that to speed up the process here and get Callie the unicorn working. So we've got Leo, Junior, Callie. Let's just keep fixing these bugs. And this printout here for I have a toy doesn't seem to be working. It says that Leo has a toy, but nothing prints out. So same process. I just want to try and find a breakpoint. I want to put a breakpoint in somewhere near to where that is happening. So maybe what I would do would be to put a breakpoint like here before the Leo picks up the ball and hit play. And then I can inspect my variables. So if I look at this, I can see all of the fields and their specific values, or I can just hover over them here and expand this. So if I expand my ball, I can see color red, name null. So almost immediately, something's gone wrong. My name is null, which would explain why nothing's printing out, because there is no name stored there. So I'm going to remove this breakpoint, and I want to put a breakpoint here right before our ball is created, and hit restart so that we trigger this earlier breakpoint, and then hit F11. So we're passing in red ball, color red. We can see those showing up here. Toy name is red ball, toy color is red. Our fields start off as null and black. If I hit F11 here, our color goes from black to red, which looks right. And then this line of code looks a little wrong. And if I hit F11, what happens is instead of our name field being changed to red ball, we've done it in reverse. We've said that this parameter should now be equal to our field. So now both of these things are null. So using the debugger, we're able to quickly find like, oh, hey, there's a value that's wrong. And then we were able to dig deeper to find the source of that mistake. So we can say our name is equal to toy name. So just removing those breakpoints, hitting play. There we go. We got our toy printing out, and it's color-coded. So we got that bug squashed. Last bug here is our happiness meter isn't currently displaying. So our happiness is a number between 0 and 10, and we wanted this bar to print out. If I run the final version, the solution here, we wanted a bar to print out. So Leo's happiness is 10, so it's a bar that's fully filled. And our parrot has 5, so half filled. And our unicorn has 3 out of 10 filled. Oh, and you know what? We can even see in my solution I made a mistake. This should be 2 instead of 3. So we'll fix both of those. So this error is probably coming from my virtual pet, and our greet function prints out the name species, calls this method for displaying happiness, and calls this method for displaying the toy's information. So I think that the problem is probably in this display happiness bar. So maybe I'll throw a breakpoint here, hit play. If I look at my call stack, we can see that we started at run. Inside of run, we got to Leo the cat.greet, and then we hit display happiness bar for Leo the cat. So Leo the cat, our dark magenta color. If I hover our happiness level, we can see, okay, that's right, it's 10. So let's look at our happiness bar. I'm going to hit F11 here to step into it. And this chunk of code is printing out happiness level with an opening bracket. So I stepped through there, and we can see happiness level with a bracket. And then we have this loop that's trying to print out an asterisk for filling in that bar, and blank spaces for areas that aren't filled in that bar. So our bar, if we had 5 for our happiness, should have 5 asterisks and then 5 blank spaces, and then it ends with this closing bracket. So if we just trace what's happening here, we're supposed to be printing out 10 things, sometimes asterisks, sometimes space. Right now we're at the first part of the for loop where the variable is initialized, our initializer. Hit F11. We can hover over I and see that I is 0. And now our condition is checked. So it's saying, is 0 greater than 10? That seems like it might be off. Let's hit off F11 and see what happens. That condition is not met, so our loop doesn't run. So we end up down here at the end of our right line. And so our happiness bar here is closed with nothing put into it. So we were trying to print out something 10 times. So 0 to 10, but our condition is backwards. We're not trying to run as long as I is greater than 10. We want to run as long as I is less than 10. So we still got a breakpoint in here. I'm just going to continue to run the code after the breakpoint, and we can see this first greet finishes running, and our bar is filled. Junior the parrot here ran up until the greet, and we hit our breakpoint again. So we can now see the call stack here was run, and inside of run, we got to Junior the parrot, and inside of there, we hit our greet function. So this kind of shows you that you can put a breakpoint in some code, like in a reusable method, and it may be triggered multiple times, and you can use continue to kind of skip around through those times. So if we step in here and let it run, we can see that now I is less than 10. So our condition is met, and this if statement, which prints out either an asterisk or a space, will run. So we can see this is true. I is less than 5. So we print out an asterisk. And then it jumps to the end of the loop, increments, checks our condition again, starts at the top of the loop, checks this. Now I is 1. Is that less than our happiness? Cool, it is. So we'll print out an asterisk. And if I bring over my terminal here, we can see that these are printing out one at a time. So we can use this to help visualize the flow of our loops and understand what is happening here. As I keep clicking, eventually our I is going to be higher than our happiness level. So I is now greater than 5. So we're now switching to printing out blank spaces. And if I just want to skip to the end, I can use run to here, and we're at the end, and our bar has printed out a bunch of asterisks and then a bunch of spaces. So now we can fix that bug that we saw that I had even in my solution, where even though, here, let's have it step one more time so that we can get the closing for our bar. So our bar printed out, and we can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 printed out here for Leo. 1, 2, 3, 4, 5, 6 printed out for Junior, even though Junior's happiness level is 5. So that gives us a clue. If we look back at our code, this is printing out, this is creating a loop that goes from 0 and stops at 10. So this is going to be a loop that runs 10 times. So that seems right. But we want to only display a filled in asterisk here if the current number that we're comparing against, the happiness level, is less than our happiness level, not less than our equal. So let's run this. I'm going to hit continue to get to the second time this runs. So we should be back at Junior the parrot. Step in here. So our happiness level is 5. So this should print out 5 stars. So our I starts at 0, then 1, then 2, then 3, then 4, then 5. So we only want this to print out for these values of our I, 0 to 1 to 2 to 3 to 4. So instead of what we've got, which is I is less than or equal to our happiness level, which is 5, we want it to be less than our happiness level so that we cut out this last value. So let's try stopping this, clearing our breakpoint, and running it. And there we go. Last bug is fixed. Our happiness level here, if we look at our world and look at our pet, 10 is Leo, so that's a full bar. 5 is Junior. 3, 4, 5. And 2 is Callie. 1, 2. So we managed to crush all of the bugs. So the debugger here allowed us to quickly hop around our code, inspect it, poke around, see what was going wrong. So it's going to be a really, really powerful tool the deeper you get into programming and the more ambitious your programs become. When you have these big programs that have a bunch of classes interacting, it's really easy to just drop like a breakpoint in and say like, well, I want to see what's happening with this class now. And you can look at its fields, you can watch some of its methods execute and see where exactly something has gone wrong. So you'll use breakpoints to open up the debugger. You'll use your step into, step out, step over, run execution to here, continue, all of those navigation tools to inspect your code in the future.